Alright, so in this video we are going to be looking now specifically at multiplying radicals. So in the last video we looked at adding and subtracting radicals, and now we're going to look at multiplying. The rules do change. With addition and subtraction, I can simplify and then combine like terms. With multiplication, I can combine anything. I have this property that says if I have two radicals being multiplied, it doesn't matter what's inside the radicals, as long as they're both the same radicals, square roots, cubed roots, I can combine them to one radical. So that's the property that we're going to use, except this time we're going to use it the other way. So before we were using it to split off and give each thing its own radical. Now we have their own radicals. We are sticking them together. So let's look at this first example. Multiply and simplify the following expression. Square root 5 times the square root of 15. So the first thing I'm going to do is the multiplied version. And so multiplied, I'm going to use that property that says that I can put these under one radical. And so I've got the square root of 5 times 15. We're going to multiply those and get that that is the square root of 75. Okay, so that's the first part. That's the multiplied part. Now I want to simplify it. And so that's going to go back to our earlier chapter where we're going to do our factor tree. And so two numbers that multiply to 75, well, I've got 5 and 15 already there. And then 15 is 5 and 3. I'm in square roots, so my pairs, one number is going to come outside and give me a 5. Other number is going to be left inside, and so I've got 5 square root 3. All right, letter B looks a little different. So letter B, I've got a number outside of parentheses. So if I saw this, what you would do is you would distribute and get 2x plus 2y. We multiplied 2 times x to get 2x and 2 times y to get 2y. I'm going to do the same thing. I'm going to take this square root 2 and I'm going to distribute it to everything inside the parentheses. So if you have a number outside of parentheses, you're going to distribute. And so what that's going to look like is each number, I'm going to put a square root 2 multiplied. Now I did a little weird order here. So notice that subtraction sign. I drop down in the middle and then I put that square root 10 in the back. It doesn't matter which way you distribute. If you want to put the square root 2 on the back of both of these so that that negative sign doesn't get lost, it's fine. Here's the negative, here's the square root 10, and then there is the square root 2 that I distributed. Now I'm going to do essentially the problem I just did on the left, except I'm going to do it twice. So I'm going to use that property backwards that says I can multiply these. 2 times 6 and then 2 times 10. Well, 2 times 6 is going to give me 12. 2 times 10 is going to give me 20. So now looking at that, you may say, I'm done, because those two radicals are not like terms, and so I cannot combine them. And remember, going back up to the last video, or adding and subtracting, while you are correct, those are not like terms, they both do simplify. So make sure we check if these radicals simplify. So let's simplify them. Square root 12, well, I'm going to work that off to the side. 12, I'm going to have a factor tree of 3 and 4, and then 2 and 2. So I've got 1, 2 coming out, 1, 3 staying inside. I'm going to do the same thing with 20, 2 and 10, 2 and 5. So I've got 1, 2 coming out, and then 1, 5 left inside. Now we get to here, they still don't simplify because I've got the square root 3 and the square root of 2. Those are not like terms, but you do have to simplify it all the way down for it to be considered correct. So you do want to simplify it even if they don't combine. All right, so the next thing we're looking at, the first thing I want us to do is talk about this shortcut. So this says the square root of something times the square root of the same thing is that thing. We've seen this in the previous chapters, but now we're officially putting this shortcut on the books. Here's an example for you. The square root of 9 times the square root of 9. Notice these are the same. They're both 9s and they're both square roots. The square root of 9 times the square root of 9, I use that property that says you can put them under one radical, and then 9 times 9 is 81, and then the square root of 81 is 9. So it extends to x's. The square root of x times the square root of x is the square root of x squared. And then we have kind of seen it, but not officially said it. The square root and squared are inverse operations, and so that means they would cancel. What does not cancel is the cubed root and squared. They have to be the same exponent as the index. So what I mean is the square root and squared cancel, and the cubed root and cubed cancel. And that, of course, would extend, but we won't really see it past cubes. So keeping that in mind, let's look at this next example. So now the difference is here. We have a number plus another number in parentheses and then being multiplied by another binomial. And so what the difference between B and C, B, I have one radical being distributed. C, I have two sets of parentheses, and that's going to be my FOIL property, which stands for first, outer, inner, last. You see the graphic over there, but it just makes more sense when we actually start doing it. So let's jump in and look at this one. The square root of 3y plus 3 times the square root of 3y plus 4. First thing I'm going to do, FOIL. And I know to FOIL because I've got parentheses times parentheses. That is your clue. Two sets of parentheses are going to be your FOIL. All right, so the first one, F stands for first. And so my first are going to be the square root 3y times the square root 3y. And I'm just going to write that for now. We'll come back and simplify it. So there's my first. Outer, the square root of 3y times 4. Now with FOIL, there is a plus sign between them. Okay, not any other operation. All right, so that's my outer. Inner, the square root, 3, so plus sign between them, 3 times the square root of 3y, and then last, 3 times 4. Now I'm going to go through and simplify each of these. And so we're going to go through across and simplify each F, O, I, and L. So let's look at F. F, square root of 3y times the square root of 3y. That's that shortcut over there because they are the exact same. And so let's do the long way just once so we can see it. The square root of 3y times the square root of 3y is the square root of 3y times 3y under one big radical. And then I could rearrange that 3 times 3 to be 9, and then y times y to be y squared. And then I could split it back up and get that the square root of 3 was y. Sorry, the square root of 9 was 3. And the square root of y squared is y to the 1 power because I partner those up to be 1. And so all of that work, I could have just written down 3y. But it certainly helps to see the longhand just in case. All right, the next one, the square root of 3y times 4. Well, I'm just going to rearrange that to be 4 square root 3y. I cannot move that 4 into the radical and say that that is 12y. That 4 is outside the radical, so it's just going to come up front. The I, 3 times the square root of 3y. Again, just 3 square root 3y. And then the L, the last one, 3 times 4 is going to give me 12. Now I go through and I look for anything that will simplify in terms of the radicals. Well, the square root of 3y and the square root of 3y do not simplify if I were to do the factor tree. And so now I just look for any like terms. Well, I do have some like terms. 4 plus 3 is going to give me 7 square root 3y because this is the part that's the like term. So I just add the 4 plus 3, and then I carry everything else down. 3y, and then plus 12 at the back. And then that would be my final answer. All right, the next one, I'm going to do exactly the same, FOIL. And so first, outer, inner, last. First, 5 square root 2 times 5 square root 2. Outer, 5 square root 2 times negative 5 square root 5. Inner, negative square root 5 times 5 square root 2. And then last, negative square root 5 times negative 5 square root 5. All right, so there's my first, outer, inner, last. Let me go through and label these in case you're looking back at these notes later. First, outer, inner, and last. Now I'm going to go through and simplify each piece down the column. And so 5 square root 2 times 5 square root 2. Well, 5 times 5 is 25. And then square root 2 times square root 2 is that little shortcut. That's the square root of 2 times 2 or 4. And so I've got a 2 there. All right, the next one. 5 square root 2 times 5, times negative 5 square root 5. Well, first, 5 times negative 5 is going to give me negative 25. And then square root 2 times square root 5. Well, 2 times 5 is going to give me square root 10. Next one. Negative, that's really a 1. Negative 1 times 5 is negative 5. Square root 5 times square root 2, again, is square root 10. And then my last one, again, a negative 1 there. Negative 1 times negative 5 is positive 5. Square root 5 times square root 5 is the square root of 5 times 5, or the square root of 25, which is 5. And so all that simplified down to this row. Now I'm going to go through and simplify some more. So 2 times 5 is going to give me 50. Carry these middle things down because they're not simplifying yet. And then 5 times 5 on the very end is going to give me 25. Now I go through and I look for like terms now that I'm adding or subtracting. And I see some like terms here in the middle. Square root 25, negative 25 square root 10 plus negative 5 square root 10. Well, negative 25 plus negative 5 is going to give me negative 30. Keep the like term of square root 10. And then I've got that plus 25 and that 50 out front. And so my final answer is, let me write it over here. Final answer, 50 negative 30 square root 10 plus 25. Now, one more thing that gets commonly forgotten, I have like terms with these numbers, which is the first time we're seeing it. 50 and 25 reduce, or sorry, they combine to give me 75 minus 30 square root 10. Final answer, all the way simplified. Everything is nice and simplified. All right.